In this lecture video, we discuss a new way to evaluate double integrals, which is using polar coordinates. So first, recall muna natin yung polar coordinate system. So take note, that's another way of representing points and curves in the plane bukod dun sa Cartesian coordinates natin. So recall, given a point in the plane, its polar coordinates are r and theta, where r is the directed distance of that point from the origin, and theta is the angle that this line segment makes with the positive x-axis. So with those definitions of r and theta, we have the following conversions between polar and rectangular coordinates. So mahalaga dito, pakialala na x is equal to r cosine theta, ang y ay r sine theta, and consequently, ang x squared plus y squared ay r squared. So, yun yung mahalagang conversions na alalahanan natin when converting between polar and rectangular coordinates. Okay, recall din natin some curves in polar coordinates, some of the most common curves. Una, pag r equals constant, ang graph no ni polar coordinates ay circle centered at the origin of radius k, where k is that constant. Theta equals constant, mga lines passing through the origin. Okay, that makes an angle of that constant with respect to the x-axis. Pag meron tayong circle na yung center naman nasa x-axis, tapos at the same time tangent siya sa y-axis, ang equation ng mga ganong circle ay r equals 2a cosine theta, where a is yung location ng center sa x-axis, pwede rin yung a yun yung radius ng circle. Similarly, r equals 2a sine theta kapag yung circle centered somewhere sa y-axis, tapos tangent siya sa x-axis. This time yung a ay yung location ng center sa y-axis, and yun din yung radius ng circle. Okay. Let's define what's called a simple polar region. So a simple polar region is a region in the plane bounded by the following. So una, dalawang rays, theta equals alpha, tsaka theta equals beta, where alpha is the smaller angle, tsaka yung difference nila is less than 1 revolution. Tapos, isa pang curve na magbabound ay r equals some function of theta, and another r equals function of theta na mas malayo sa origin kaysa dun sa unang curve. Okay, so with these four curves, yung region na binabound nilang apat, yun yung simple polar region. As a specific example or a special case nitong simple polar region, we have a polar rectangle na mangyayari when yung r equals function of theta ay mga r equals constant. So in other words, yung mga green curves na to ay mga circles centered at the origin. Okay, so pag ganyan, polar rectangle ang meron tayo. Okay, so ang gagawin natin dito, we will define what it means to get the double integral of a function of r and theta over a simple polar region. Okay. So, formally, de-define muna natin siya. So, yung pag-define natin dito, we follow a process katulad ng ginawa natin sa double integrals in rectangular coordinates. So, actually, almost all the same steps, pero magkaiba lang doon sa una, which is yung subdividing into smaller parts. This time, imbes na isa-subdivide natin yung region into rectangles, we subdivide the region into polar rectangles using lines coming from the origin or rays coming from the origin and circles centered at the origin. So using those, we divide the region R into polar rectangles. Let's say merong n na polar rectangles. Okay, then suppose din natin na bawat polar rectangle, ang dimensions niya ay delta theta tsaka delta r. So delta theta is just this angle na ginagawa ng polar rectangle. Okay, tapos delta r is this length. Okay, makita natin sa next figure. Okay, so this is delta r. Okay, tapos we let rk star, delta k star be the polar coordinates of the center of rectangle rk. So center siya so that yung distance niya between ang distance niya to the adjacent na circular sides, itong sides na to ay delta r over 2. Okay, so ang gagawin natin, kukunin natin yung area of 1 r sub k na tatawagin natin delta a sub k. Okay, so take note, yung itsura nito ay isang difference of two sectors. So recall muna natin yung formula ng isang sector, which is 1/2 r squared theta, where yung r yung radius, yung theta is yung included angle in radians. Ayan, so ito ulit yung RK natin. So take note again, it's a difference of two sectors. So yung area nito is just a difference of dalawang formula lang ng area ng sector. So yung take note, yung outer sector natin has radius RK star plus delta r over 2. So magiging ganito yung area. Tapos isusubtract natin itong part na to para matira yung r sub k natin. Yung radius nitong smaller sector ay rk star minus delta r over 2. So, therefore, yung difference ng dalawang to, yun yung delta a sub k. Ayan, tapos, so, this is an expression for delta a sub k. Just simplifying, both terms parehong may 1/2 delta over 2, so pwede factor out yun. Tapos, after some algebraic manipulation, so pwedeng expand, or pwede tingnan to as difference of two squares. In any case, simplifying all of these, magiging rk star delta r delta theta. So again, this expression is yung area ng isang simple polar rectangle ng isang r sub k. Okay, so with that, we form yung Riemann sum katulad na to nung step from the original definition ng double integral. So we form this sum. So delta AK again, area to ng isang simple polar region. F of RK star delta K star. One way of looking at this, ito yung height, kung maalala nyo. So that this Riemann sum approximates yung volume under the surface for the volume problem. Okay? Pero for this case, kapag naka-polar coordinates tayo, again, yung delta AK, napakita natin kanina, is RK star delta R delta theta. Okay, so again, this expression, approximation to nung volume if we are answering the volume problem. Anyway, so letting n approach infinity, we get the formal definition ng double integral of a function in polar coordinates over the simple polar region R, which is this limit. Okay, limit ng isang Riemann sum. Pero, as usual, hindi natin gagamitin yung formal definition na to evaluate double integrals. Okay, what we will use instead is the following theorem. Na if f of xy is continuous on this simple polar region, okay, which is illustrated on this figure on the right, ito siya in symbols lang. Then, okay, to evaluate the double integral of f of xy over such a region, ay sabi ng theorem, so una, yung integral natin, which is in terms of x and y, gagawin natin in terms of r and theta by replacing x by r cosine theta and replacing y by r sine theta. Tapos, ang importante din makita dito na yung dA natin kapag using polar coordinates ay r dr d theta. So, hindi lang siya dr d theta, merong r. Okay, tapos, for such a region, ang bounds natin for r ay from r1 of theta to r2 of theta, and theta is from alpha to beta. Okay, so again, pakialala na pag nagagamit tayo ng polar coordinates, convert lagi natin yung xy to polar coordinates, to r cosine theta to r sine theta. Tapos, yung dA ay r dr d theta. Okay, tapos, for setting up these limits of integration, we can do the following. Okay, so to find the bounds of integration or the limits of integration. So una, parang sa ginagawa natin before sa double integrals, kailangan may sketch tayo ng region. Otherwise, medyo mahirap kunin ng bounds, diba? Kapag wala tayong sketch ng region. Okay. Tapos, after sketching the region, make sure na yung mga curves na involved ay nakasulat in polar coordinates. So, yung mga curves nakasulat sana as r equals function of theta. Ayan, so tapos upon setting up that sketch, to find the bounds for R, ang pwede nating gawin ay ganito. Try to sketch or try to at least imagine segments or rays coming from the origin papunta dito sa region natin. Okay? So, iba to sa vertical o horizontal strips. So, bagong klaseng strips to. So, try to sketch strips coming from the origin papunta dun sa region natin. Tapos, mangyari, ang unang matatamaan na curve, yun yung lower bound natin for R. So, in this illustration, yung R1 of theta, yung unang matatamaan na curve. So, yun yung lower bound. Tapos, yung huling matatamaan before exiting the region, yun yung upper bound natin for R. Ayan, so that's how we determine the bounds for R. Tapos, to determine the bounds for theta, tingnan lang natin yung region, tapos tingnan natin kung anong angles yung covered niya. So, take note for this illustration, yung angles covered here ay from theta equals alpha to theta equals beta. Tapos, pakialala na lagi, ang ating theta, ang pag-measure natin sa theta ay counterclockwise. So that, yung lower bound na alpha, lagi dapat na mas maliit siya dun sa beta. Ayun, so, I guess mas madaling maintindihan to through example. So, let's do some examples.